To a great extent, this supplemental lighting enables us to enjoy fresh herbs and salad greens year-round in this small lean-to greenhouse. The plant lighting we will be discussing in this chapter includes high-intensity lights, which have proven to be excellent for all stages of plant growth. Fluorescent lighting offers a more economical alternative to high-intensity discharge lighting and are available in several wattages and color outputs. Light-emitting diode, or LED lights, have more recently appeared as effective plant lights. In many cases, you will find that combining lights, HID with fluorescence or fluorescent with LED, will provide the best all-around plant development. Plants use sunlight or proper frequencies of artificial lighting for growth and development. The specific color or frequencies of light used by the plant fall within the limited band of visible light. Visible light is part of the electromagnetic spectrum we can actually see. It is a very small portion of the light spectrum directly between infrared and ultraviolet. If you think about it, this very narrow band of visible light is the energy that supports all life as we know it. It certainly supports plant life, which, in turn, provides oxygen and food for all animal life. Photosynthesis is the process that, due to the interaction of visible light and vegetation, enables the plant to produce sugar and oxygen. Photosynthetically active radiation denotes the area of the visible spectrum pertinent to plant photosynthesis. Plants use two major frequencies or colors in this area: blue for vegetative growth and red for flowering development. These same colors also correspond to the frequencies chlorophyll absorbs. Note the low intensity in the green range. This area is reflected from the plant, which is why we see most leaves as green. The amount of light illuminating your garden can be measured with a light intensity meter. This measurement is especially useful when initially setting up your garden to determine light requirements and placement. Indoors, once adequate light has been established, it can easily be maintained and lamp replacement can be determined by decreased light intensity measurements over time. There are basically two types of light meters: digital and analog. The digital is used for more precise indications, but the analog meter also works well and is usually adequate for most garden applications. This indication of around 2,500 foot candles worked very well for our indoor garden. High-intensity discharge lights provide powerful lighting at various frequencies. The light bulbs themselves consist of a gas or vapor-filled sealed chamber surrounded by an air-evacuated glass envelope. The intensity of light radiation from these bulbs at any wattage creates very intense heat. Caution must be used when operating these lights. Do not touch until completely cool, and do not splash with water under any circumstances. A water splash could cause a hot bulb to shatter. One of the most popular HID grow lights is the metal halide. The metal halide is a full spectrum bulb that provides adequate blue frequencies, excellent for the vegetative growth stage. Also very popular, the high-pressure sodium light is a full spectrum light as well, providing intense yellow to red frequencies, enabling flowering and fruit production. There are several color-enhanced HID lights available that provide both blue and red frequencies that will work well for the entire growth cycle for many plants. All high-intensity discharge lights must be ignited by some sort of electrical ballast. The high-intensity discharge transformer ballast has been around for decades and is still widely used because of proven reliability. Its main component, the auto transformer, is often a multi-voltage type which can use one of several different available input voltages. The high-pressure sodium ballast is basically the same as the metal halide ballast, except that a starter circuit has been added. A note of importance: these ballasts are not interchangeable. In other words, a high-pressure sodium lamp cannot be used in a metal halide ballast, and vice versa. A newer, more modern ballast option is the electronic digital ballast. The advantages of the digital ballast include: number one, it is much lighter, which of course makes it easier to install, and perhaps a more important advantage is that a single ballast can activate either a metal halide or a high-pressure sodium bulb. Basically, the amount of illumination in your garden depends a great deal on the quantity of lights, bulb wattages, and so forth. However, the amount of light your actual growing area receives mainly depends on light placement and light concentration. This small flower garden is illuminated by a sun system light in a horizontal reflector. A horizontal reflector, or hood, concentrates the light downward in a relatively small rectangular area. The amount or intensity of light received by the plants also depends on the type of reflective material inside the hood. A horizontal hood would be used for gardens requiring maximum light. The lettuce garden in this homemade aeroponic system did exceptionally well under a 250 watt metal halide light in a horizontal hood. The round reflector disperses light over a wide area and would most likely be used for supplemental lighting or gardens requiring less energy. The parabolic reflector concentrates light less but covers a considerably larger area than the horizontal reflector. It is generally used for larger gardens with fairly high light requirements. Here are recommended garden area sizes based on light wattages. For example, a 400 watt high-intensity discharge light covers an area approximately 4 feet by 4 feet. A 600 watt an area 5 feet by 5 feet, and so on. Keep in mind that the reflector type and size is also a factor, as well as the distance the light is located from the garden. Height distances are also just basic recommendations and can be varied, especially by use of a light mover. A light mover is a good way to increase the garden area covered without adding additional lights. This horizontal light mover automatically moves the light back and forth in a straight line across the garden. Since the light is constantly moving, the fixture can be located closer to the plants without fear of burning the plant tops. The large sweet basil plants in this subaerated system developed with exceptional results under a 400 watt metal halide on a light rail. Another light mover option is a circular light mover. Some of these units can move the lights continuously in a 360-degree circle. These movers come with a 1 to 4 arm option. They are a bit more complicated to install than the horizontal light mover, but well worth it for large indoor gardens. Fluorescent plant lighting has been vastly improved over the past decade. Lights that were once used mainly for seedlings and cuttings can now be used for many higher energy plants. For example, these compact fluorescent bulbs can be up to 200 watts, radiate a good color frequency for growing and blossoming, and, since they are much cooler than the HID lights, can be placed much closer to the plants. To cover a wider area, the high-output T5 fluorescent tube is a good option. These tubes are available in 2 or 4 foot lengths in fixtures or as individually operated single tubes. Fluorescent plant lights can be used as standalone units or as a supplement to HID lighting. As with house lighting, and more recently automobile lights, LEDs have several features that makes them desirable for plant lighting as well. There are 3 main reasons why LED lights are very appealing and may be considered for plant growth. Number 1, LEDs require very little power to operate. Number 2, LEDs produce very little heat. And number 3, LEDs can be manufactured with a very specific color output frequency. This graph shows the relationship to visible light frequencies of outputs from metal halide, fluorescent, and LED lamps. As indicated, the LED lamps, the green curve, are closer to the optimum frequencies for both the grow and bloom stages of plant life. All of these factors combined may indicate that the light-emitting diode may truly be the plant light of the future.